This is Algebra 2. It's a question about finding the discriminant and evaluating the discriminant of a quadratic equation. There's two types of, well, I guess there's only one type of discriminant or discrimination. It could be used for negative purposes. For example, if I have a job for someone to write software and I say, I don't want a bald guy writing software at my company, his head is shiny, and I don't like that. I don't like shiny head bald people. Well, it has nothing to do with the job. That would be the bad kind of discrimination. But what if the job was to be some kind of a hair product model? And you say, well, I don't want bald people because I have to have someone who has hair. Well, that would be good type of discrimination, good discriminant, because you're saying, I want the person with good hair so my product looks good. So in this case, for the quadratic formula for quadratic equations, the discriminant is a type of discrimination that lets you tell between two things. And remember, the quadratic formula is negative b. I like to use a different pen here. Plus or minus the square root of b squared minus 4ac, all divided by 2a. And that's when you have ax squared plus bx plus c equals 0 or equals y. This, b squared minus 4ac, is the discriminant. If the discriminant is equal to 0, then there is one real solution. And it is rational. That's another piece you can know. It's rational. A rational is a fraction that can be expressed as one integer divided by another, where a and b are integers. So if b squared minus 4ac is 0, one real solution, and it's rational. If it's greater than 0, there's two real solutions. And if it's a perfect square, I'll just write PS, then they're rational. In other words, if it's 1 or 4 or 16 or 36 or 49 or 64, perfect squares, numbers that have a square root that's an integer, then it's rational. If it's not a perfect square, then it's not rational. And then if it's less than 0, there are no real solutions. Let me zoom out a little bit and get a little bit of extra room. There are no real solutions if it's less than 0. Let me put a line here so I'm differentiating. No real solution. There are two complex solutions with a non-zero imaginary component. In other words, a plus bi is a complex number. If the discriminant is less than 0, it's something like 3 plus I, or 3 plus 2i, or 82 minus 4i. There's an I in there. This is the real part. This is called the complex part, the part that's with I. It's a non-zero imaginary component if it's less than 0. So here's a specific example. I've got negative 7r squared minus 10r plus 6. And I want to use the discriminant to find out what the nature of the solutions, how many and what the nature is. All right, so first of all, I always want to have the number in front of r squared positive. So I'm going to add 7r squared. It's minus 7r squared. I'm going to add 7r squared to both sides. So this 0 equals 7r squared minus 10r plus 6. A is 7, b is negative 10, c is 6. The discriminant is b squared minus 4ac, which equals negative 10 squared minus 4 times 7 times 6. 7 times 6 is 42. 42 times 4 is 168. Negative 10 squared is 100 minus 168. That's less than 0. That means there are two complex solutions with non-zero imaginary component. In other words, there's an I in there. And oh, by the way, one more thing. When it's too complex with an I or too complex with non-zero imaginary component, they're neither rational, they are not rational, and they're not irrational. It's neither one. It's neither rational nor irrational. So in this one, the discriminant was negative. So it's too complex with a non-zero imaginary component or too complex with I, and they're both going to be neither rational nor irrational.